Welcome, dear friends, to saitechinfo, your gateway to a world of knowledge and inspiration. Let us navigate the fascinating realms of knowledge across the 4S pillars: science, society, spirituality, and sustainability. Science. At saitechinfo, we are more than just a YouTube channel. We are your go-to destination for a diverse range of content that caters to the curious minds of coaching school and college students. Our commitment extends beyond academics as we provide invaluable career guidance and counseling to help you navigate the path to success. But that's not all. We specialize in corporate training, delving into the fascinating realms of coating technology and advanced smart materials, including the revolutionary world of nanomaterials. Our mission is to equip you with the skills and insights needed to thrive in today's fast-paced world. saitechinfo is not just about education, it's about empowerment. We create engaging concept videos that span the spectrum of science, technology, engineering, mathematics, medicine, and management, a holistic approach to nurturing well-rounded individuals. Society. But our journey doesn't stop there. saitechinfo is committed to shedding light on societal matters that shape our world. We engage in meaningful conversations about the interconnectedness of individuals and communities, fostering a deeper understanding of the world we live in. Spirituality. In the pursuit of knowledge, we recognize the importance of delving into the spiritual dimensions of life. saitechinfo invites you to explore the enriching world of spirituality, encouraging introspection and a harmonious connection with the inner self. Sustainability. And as stewards of our planet, we champion sustainability, recognizing the urgent need to preserve and protect our environment. Join us as we discuss eco-friendly practices, cutting-edge technologies, and sustainable solutions to create a better future for generations to come. saitechinfo, where science meets society, spirituality, and sustainability, fostering a holistic understanding of our world. Your support means the world to us. Subscribe, comment, and share our content with your friends and relatives. Your encouragement fuels our passion for content creation. For those seeking a deeper dive into premium courses, connect with us directly on our Telegram channel, saitechinfo, or WhatsApp to 9444929163. Join us on this exciting journey of exploration and learning. saitechinfo, where curiosity meets knowledge and inspiration takes flight. Subscribe now and let the adventure begin.
Hi friends, இன்னைக்கு நம்ம பெயிண்ட் இண்டஸ்ட்ரீஸில் ரெசினோட பார்ட், ரெசின் அப்படின்னாலே பாலிமர், அதனுடைய பார்ட்டை பற்றி பார்ப்போம். ஆக்சுவலி ரெசின் மேக்கிங் இஸ் த ஹார்ட் ஆஃப் த பெயிண்ட் இண்டஸ்ட்ரி. ஒரு நல்ல பெயிண்டோட குவாலிட்டியை தீர்மானம் பண்ணுறது எந்த பார்ட் அப்படின்னு பார்த்தீங்கன்னாக்கா ரெசின் தான். ரெசின் இஸ் நத்திங் பட் வார்னிஷ், சிம்பிளி ஸ்பீக்கிங் வார்னிஷ் அப்படின்னு சொல்லலாம். அதை கெமிக்கலாக சொல்லணுன்னா பாலிமர் அப்படின்னு சொல்லலாம். இந்த பாலிமர் பெயிண்டில் யூஸ் பண்ணுறதோட பர்பஸ் என்ன? பெயிண்ட் கேனில் இருக்கிறப்போ பெயிண்ட் லிக்விடாகவும் அதை வெளியில் கோட்டிங் பண்ணதுக்கப்புறம் ஏதாவது ஒரு சப்ஸ்ட்ரேட் மேலே கோட்டிங் பண்ணோன்னே அது என்ன ஆயிடுது? அது ஒரு ஃபில்மாகவும் மாறுது. அந்த ஃபில்ம் இந்த சப்ஸ்ட்ரேட் மேலே நல்ல பிடிமானமாக இருக்குது. அதை தான் அடேஷன் அப்படின்னு சொல்லுவோம். ஸோ இந்த அடேஷன் அதோடு இல்லாமல் இந்த லிக்விட் பெயிண்ட்டாக இருக்கிறப்போ அது லீனியர் பாலிமராக இருக்குது. சின்ன சின்ன அப்படியே ஒரு துண்டு துண்டாக நீளமாக இருக்கும். அதோடைய மாலிகுல் லெவலில் பார்த்தோம்னா, அதாவது ரெசினஸ் மெட்டீரியல், அதாவது பாலிமர் ஆஸ் அ ஹோல் பெயிண்ட் அப்படின்னு சொல்லலாம். அதுவே அடித்ததுக்கப்புறம் ஒரு ஃபில்ம் ஃபார்மேஷன் ஏன் வருது அப்படின்னா, சப்போஸ் அது ஆக்சிஜன் மூலியமாக ட்ரை ஆகுது. இட்ஸ் கால்ட் ஆக்சிடேட்டிவ் ட்ரையிங் அப்படின்னு சொல்லுவோம். அப்போ அந்த ஆக்சிஜன் மாலிகுலில் ட்ராப் பண்ணோன்னே கிராஸ் லிங்க்டு பாலிமராக மாறிடுது. அப்போ பெயிண்ட்டோட ட்ரையிங் மெக்கானிசம் அப்படின்னு பார்த்தீங்கனாலே லீனியர் பாலிமர், லிக்விட் லெவலில் லீனியர் பாலிமராக இருக்கிறது ஃபில்மாக மாறுறப்போ அது கிராஸ் லிங்க்டு பாலிமராக மாறுது. இந்த கிராஸ் லிங்க்டு பாலிமர் ஒன்றோட ஒன்று நல்ல அட்ஹெஷன் கொஹஷன் இருக்கணும். அதாவது இன்டர்மாலிகுலர் ஃபோர்ஸ் நல்ல பக்கா பைண்டிங் இருக்கணும். அதோடு இல்லாமல் எந்த சர்ஃபேஸ் மேலே நாம் பெயிண்ட் அடிக்கிறோமோ அது மேலேயும் பைண்டிங் இருக்கணும். அதுதான் அட்ஹெஷன் அப்படிம்போம். ஆக்சுவலாக தேர் ஆர் 2 types ஆஃப் அட்ராக்டிவ் ஃபோர்ஸஸ் இந்த இடத்துல. ஒன்று இந்த பெயிண்ட் ஃபில்மு சப்ஸ்ட்ரேட் மேலே நல்ல ஸ்ட்ராங்காக அட்ஹெஷன் ஆகணும். இன்னொன்று தனக்குத்தானே ஒன்றோட ஒன்று பிணைப்பாக இருக்கணும். அது கொஹஷன் அப்படிம்பாங்க. ஸோ இந்த கொஹஷன் அண்ட் அட்ஹெஷன் இந்த ரெண்டுத்துக்கு டிஃப்ரென்ஸ் என்ன அப்படின்னா, கொஹஷன் அப்படிங்கிறது இன்டர்மாலிகுலர் ஃபோர்ஸ் ஆஃப் அட்ராக்ஷன். தனக்குத்தானே மாலிகுல் ஒன்றோட ஒன்று ஒரு பிணைப்பை ஏற்படுத்திக்கிறது. அது மூலியமாக ஒரு கிராஸ் லிங்க்கு. ஒன்ஸ் கிராஸ் லிங்க் ஆனோன்னா 2 விதமான சப்ஸ்ட்ரேட்டு, 2 different சப்ஸ்ட்ரேட்டில் இந்த அட்ராக்ஷன் ஆகணும். அதுதான் அட்ஹெஷன் அப்படின்னு சொல்லுவோம். இப்போ நம்ம அட்ஹெசிவ், ஒட்டும் பசை, கம் எல்லாம் சொல்கிறோம்ல, அதே மாதிரி தான். ஒரு சப்ஸ்ட்ரேட் மேலே ஒரு கம்மை தடவினோம்னா இன்னொரு சப்ஸ்ட்ரேட்டு ஒட்டணும். ஸோ 2 different சர்ஃபேஸில் ஒட்டிக்கிற நேச்சரை தான் அட்ஹெஷன் சொல்லுவோம். ஒரே சர்ஃபேஸில் இருக்கிறப்ப அதை கொஹஷன் சொல்லுவோம். இப்போ புரியுதுங்களா? ஸோ கொஹஷன், அட்ஹெஷன் இந்த ரெண்டுமே பெயிண்டோட முக்கியமான ப்ராப்பர்ட்டி. அது எது தீர்மானம் பண்ணுது அப்படின்னா இந்த ரெசின் தான். ஸோ அதனால தான் பெயிண்ட் பண்ணுறப்போ இந்த ரெசினோட குவாலிட்டி ரொம்ப ரொம்ப முக்கியமானது. இப்போ இந்த ரெசினோட கண்டென்ட்டு ரொம்ப கம்மியாக இருந்தது அப்படின்னா, ரொம்ப ரொம்ப கம்மி அப்படின்னா அது ஒரு மேட் ஃபினிஷை கொடுத்துரும். கொஞ்சம் ஜாஸ்தியாக இருக்குது, ஒரு அரவுண்ட் ஒரு 30 to 30%னாக்கா ஒரு செமி மேட் மாதிரி வரும். செமி கிளாஸின்னு சொல்லலாம், ஒரு 40-35 ரேஞ்சில். அப்புறம் ரெசினோட பர்சன்டேஜ் ஆல்மோஸ்ட் 50% கிட்ட வந்துடுச்சு அப்படின்னா, இல்லை ஈவன் 55 அந்த ரேஞ்சில் இருந்தது அப்படின்னா, அந்த டயத்தில் என்னன்னாக்கா ஒரு நார்மலான கிளாஸி பெயிண்ட், அதுக்கப்புறம் சூப்பர் கிளாஸி பெயிண்ட், அதுக்கப்புறம் இன்னும் இன்க்ரீஸ் ஆச்சுன்னா அதான் பிக்மெண்ட்டே இல்லைன்னு அர்த்தம். அதுதான் என்னது? வார்னிஷ். ஸோ பிக்மெண்ட்டே இல்லாத ஒரு பெயிண்ட்டை என்ன சொல்லலாம்? வார்னிஷ்னு சொல்கிறோம். அதுதான் நாம் வுட் சர்ஃபேஸில் அடிக்கிறோம். இது ஏன் சார் மெட்டல் மேலே வார்னிஷ் அடிக்கிறது இல்லை? மெட்டல் மேலே வார்னிஷ் அடிக்கிறதுக்கு காரணம், அடிக்காததுக்கு காரணம் என்னென்னா, அந்த மெட்டல் சர்ஃபேஸில் அப்படியே தெரியும். ஆனால் இப்போ அது அடிக்கிறாங்க, வார்னிஷ்னு சொல்கிறதில்ல, நம்ம அதை கிளியர் கோட்டுன்னு சொல்கிறோம். இந்த வுட்டன் ஃபினிஷுக்கெல்லாம் வார்னிஷ்னு சொல்கிறோம். அது பிக்மெண்ட்லெஸ் பெயிண்ட் அப்படின்னு சொல்லலாம். ஸோ அந்த வுட்டு மேலே அடிக்கிறப்போ அந்த வுட்டோட நேச்சுரல் ஸ்ட்ரெயின்ஸ்லாம் தெரியணும், அதோட பேட்டர்ன்ஸ்லாம் தெரியணுன்றதுக்காக தான் இந்த மாதிரி டிரான்ஸ்பரண்ட்டான வார்னிஷை நம்ம பண்ணுறோம். இப்போ ஒரு நல்ல டீக் வுட் வாங்கி அதில் சாலிட் பெயிண்ட் அடித்தோம்னா அதை போல் கேவலம் எதுவுமே கிடையாது. ஸோ நாம் அந்த பெயிண்ட்டோட வுடன் கிரெயின்ஸ், அதோட பேட்டர்ன், அதோட டிசைன், அந்த டீக்கோட பேட்டர்ன்ஸ்லாம் தெரியணுன்னா அருமையான ஒரு கிளியர் கோட்டு தான் அடிக்கணும், வார்னிஷ் தான் அடிக்கணும். அந்த வார்னிஷை ஸ்ட்ரைட்டாக அடிச்சிடலாமோ? அடிக்க முடியாது. ஸோ அந்த இடத்துல ஒரு டிரான்ஸ்பரண்ட்டாக இருக்கணும். அதே டயத்தில் சர்ஃபேஸை ஈவனாக ஃபில்அப் பண்ணணுன்றதுக்காக நம்ம சாண்டிங் சீலர் அப்படின்னு சொல்லிட்டு இந்த வுடன் ஃபினிஷுக்கெலாம் கொடுப்போம். அது டிரான்ஸ்பரண்ட்டாக ஒரு டிரான்ஸ்லூசண்ட்டாக இருக்கும். ஸோ தட் அந்த ஹெல்த்தி வுடன் லுக்கை அருமையாக அப்படியே ரிச் லுக்கை எடுத்துகிட்டு வரும். அது மேலே நம்ம வார்னிஷ் அடித்தோம் அப்படின்னா அந்த வார்னிஷ் உரிகிற தன்மை கம்மியாக இருக்கும், கிளாஸினஸ் பெட்டராக இருக்கும், கவரேஜ் பெட்டராக இருக்கும். ஸோ அதனால தான் வுடன் ஃபினிஷ் அப்படிங்கிறப்போ ஒரு சாண்டிங் சீலர் அடிச்சுட்டு அதை சாண்ட் பண்ணிவிட்டு ஸ்மூத்தன் பண்ணிவிட்டு அதுக்கு மேலே நம்ம வார்னிஷ், அதாவது ரெசின் அப்ளை பண்ணோம்னா, கிளியர் கோட் அப்ளை பண்ணோம்னா சிறப்பாக இருக்கும். ஆனால் வுட்டில் அடிக்கிறப்ப சாலிட் பெயிண்ட் அடிக்கணும். சில டயத்தில் இப்போ காப்பர் இருக்குதுன்னு வச்சுக்கோங்களேன், அந்த காப்பரில் என்ன பண்ணலாம், நல்லா பளபளன்னு சுத்தமாக அதை க்ளீன் பண்ணிவிட்டு நல்லா அது அட்ஹெஷன் இருக்கணும், அது ரொம்ப முக்கியம். ஸோ அந்த பளபளப்பான ஒரு காப்பர் சர்ஃபேஸ் மேலே இப்போல்லாம் என்ன பண்ணுறாங்கன்னாக்கா PU கிளியர்லாம் கொடுக்குறாங்க. ஸோ இந்த மாதிரி PU கிளியர் கோட் கொடுத்தோம் அப்படின்னா அந்த காப்பர் ஒரிஜினல் லுக்கு அப்படியே இருக்கும். இப்போ ஒரு நிறைய நாங்கள் கூட ட்ரை பண்ணியிருக்கோம். இந்த கும்பம்னு சொல்கிறோம்ல ஆலயத்துக்கு மேலே, ஸோ அதில் கூட இந்த மாதிரி பாலியூரித்தேன் கோட் கிளியர் கொடுத்தோம்னா ரொம்ப பிரமாதமாக இருக்கும். ஆனால் அது வந்து பிளமிஷ் ஆகாமல் இருக்கும். எப்போதுமே காப்பரை வந்து க்ளீன் பண்ணிவிட்டு 2 நாள் கழித்து பார்த்தீங்கன்னா மறுபடியும் கருப்பாயிடும், அதாவது பச்சையாக ஒரு மாதிரி மாறிடும். ஆனால் இந்த மாதிரி கிளியர் கோட் அடிச்சிட்டோம்னாக்கா அது ரொம்ப நாளைக்கு ரொம்ப வருஷத்துக்கு அப்படியே நிற்கும். ஸோ இந்த கோட்டிங்கை எப்படி அதில் நல்லா ஸ்ட்ராங்காக அடேரன்ஸ் பண்ண வைக்கிறது, ஒட்ட வைக்கிறது, அங்கே தான் ஒரு சில முக்கியமான வேதிப்பொருட்கள்லாம் நம்ம சேர்க்க வேண்டியிருக்கு. ஸோ அதை பற்றி அடுத்த லெக்சரில் நம்ம பார்ப்போம். Hi friends, welcome to this technical series on surface coatings. Here you can see some luminescent coating on the highways. This is very helpful for the day and night vision. Actually, this is the functional purpose of paint. So these are all called nowadays smart coatings. Now let me discuss about the overall purposes of paints. And before that, let us try to understand the ingredients of paint. Paint essentially consists of 4 important ingredients: pigment, resin, solvent, and some additives. Additives are small chemicals added in small quantities to serve certain purposes like enhancing the drying time or drying, or improving the adhesion, or providing the water resistance, then to avoid the skinning of paints, etc. Now let me focus on the pigment. This can be classified into 2 parts, that is true pigment and false pigment. True pigments, actually they are imparting colors, they offer colors. The coloring matter, which is nothing but some inorganic or organic materials. Whereas extenders, which are the false pigment, it is used just to fill up the surface. In fact, by incorporating this, you can reduce the cost also. But at the same time, extenders do not have hiding power, whereas true pigments have better hiding power. Because the purpose of painting, the purpose of coating a paint on a surface is to hide the surface, is it not? So the hiding power is very, very important as far as pigment is concerned. We have 3 values of a paint. One is aesthetic value, that is, it has got the decorative value. It is to enhance the beauty of a surface. Secondly, it acts as a protective coating that works against corrosion, weather, humidity, fouling, microbial attack, etc. And there is a third aspect about the paint, that is called the functional use of paint. It is used to serve a particular function. For example, as we already discussed in the introduction, the application of luminous paint on the highways, the tar road, where fluorescent or black and white paints are applied. Of course, they are applied on the trees on the sides of the highways also. It helps the driver for smooth traveling. And there is another type of paint called sound deadener. It reduces the vibration noise of a sheet metal component. Particularly, it is used in buses and trains. So they are called acoustic paints. So these are the functional uses of paint. Now, as I already explained, I have shown here some luminescent coatings, and you can find in some interior, that is indoor paintings also. Now, what are the major ingredients of paints? As I already discussed, pigment, that is the coloring powder, and extender, it is the false pigment. Then resin, that is the important component of the paint, which is nothing but the polymer or varnish. Then we have got some mixture of petrochemical solvents, alcoholic solvents, ketonic solvents, etc. And we have some additives. When we think of paint, that is, we are very much interested in colors, and the pigments are responsible for importing colors. They are the coloring matter. In fact, pigments can be broadly classified into inorganic and organic. Inorganic pigments are metal-based oxides, chlorides, sulfates, and some minerals, etc. There are some natural inorganic pigments, and they are inorganic minerals, we can say. And similarly, nowadays, variety of modern organic pigments have been tried also. Now, the pigments can be broadly classified into, as I already suggested, inorganic and organic, where we have got white in inorganic and colored in inorganic. In white, particularly, it gives more opacity, so it is called opaqueness. And titanium dioxide, zinc oxide, lithopone, zinc sulfide, they give better opaqueness, that is opacity, hiding power. There are some non-opaque, that is non-hiding pigments like calcium carbonate, talc, barium sulfate, mica, silica, clays, etc. They are all called pseudo pigments or false pigments. They can also be called the extenders. By adding suitably, we can reduce the cost also, but without compromising on the hiding power and other important quality parameters of the finish. Now, let me come back to the colored inorganic pigments. They can be classified into natural and synthetic. Natural pigments are ochres. The yellow ochres are very popular. Umbras, then hematites and magnetites. And then we have variety of synthetic inorganic coatings. And we have got cobalt blue, cobalt green, iron browns, and we have got some rutile of nickel titanium yellow, chromate titanate, manganese titanate browns are very, very popular. Then we have got metal oxides like iron oxides, chrome oxides. Then we have got some metals, salts like chrome yellow. We have got different types of chrome yellow also, like lemon chrome, middle chrome, orange chrome, etc. Then we have got molybdenate orange, iron blues, and we have got other pigments like ultramarine blue, metallic pigments, carbon blacks. So these are all very popular synthetic compounds. And we have some phosphates also. Now let me explain one by one. Let me talk about these natural pigments. By its nature, after all, by its name, it's naturally available. They are all excavated from minerals. For example, this is yellow ochre, which gives yellow shades. And we can make use of different yellow shades by making use of different pigments obtained from different locations. Their tonal variations are very useful for us to give more different colors. This is the yellow ochre from another location. You could have seen these two difference. The difference between these two types of yellow ochres obtained from different locations. Now this is darker and this is brighter. Then these in those days, these yellow ochres and iron oxide yellows were used in ceramics. Ceramic pots are very popular with these yellow oxides. Indians and the Chinese, they have expertised in coloring ceramic materials. Generally, inorganic pigments are heat resistant. And we have got ambra pigments. Then we have got a variety of German, Japanese, Chinese and Asians. They have expertised in this field actually. Now, umbra, which gives a beautiful coffee brown color. Now, in fact, that is several pigments have been used in olden days also. Hematites are iron-based pigments, and we have got magnetites. They have got the magnetic properties. These magnetic infused concrete pipes are very, very popular. besides natural pigments, they are more synthetic and inorganic pigments. Now let us talk about metal oxides. Titanium dioxide is a major white pigment used in paint industries. Its brightness is something unique. Titanium dioxide pigment, they have got two types of crystal structures, rutile and anatase, TiO2, titanium dioxide. These rutiles have they have got a better that is opaqueness, that is hiding power than anatase. Of course, anatase type of titanium dioxide is used in water-based emulsion, distemper and wall paints, whereas rutiles have got very good usage in good quality oil-based paints because they have got more hiding power than anatase, and its covering capacity is great. There are some properties of pigment. First of all, that is, it should give everlasting color, and it should have good hiding power, that is called opacity of the pigment. In fact, we can check the opacity of a red pigment like this. We can apply the paste of fixed quantity of pigment with the proper ratio of a particular resin or varnish or oil, and this can be applied on various surfaces. Thereby you can see the difference in the opacity. Of course, that is the good one will definitely hide. For instance, we have applied that is a white paint on the red surface, where you can see here it is totally opaque in the last case. Okay, so here it is almost transparent, so it means the hiding power is greater. So similarly, red pigment can be tried on the white surface. For instance, here we have tried the red pigment, so the opacity is superior here, is it not? And when it goes like this, when it is coated with a different opaqueness, you can see that is its hiding power is the least as the that is opacity goes down here. So it means that is its coverage is very poor when the opacity is the least. Then the red pigment totally covers the white surface. In the first case here, it is measured as 1.0. So it means it has got the fullest opacity. Opacity means hiding power. Now you can see the red becomes transparent slowly with fading also. So naturally, when the opacity goes off, it gets deteriorated also, and it may get fading very soon, and that is not a good pigment. Now let us talk about the dye. The dye gives color but does not give opacity, so that makes the difference. In fact, some people cheat coating inorganic with some artificial coloring dyes, but take care, by bleeding properties it can be easily found out. So there is one bleed test, that is with which we can easily find out the contamination with some rich dye, but it may easily fade off. And then that is pigment quality is very important in this case. So that is, let us talk about this titanium dioxide. Titanium dioxide, as I already explained, that is, it has got the two crystalline nature, that is anatase and rutile. Rutile has got better opacity than anatase, and that is why rutile is used in superior quality paints, that is oil based paints, whereas anatase is more comfortable with that is emulsion type of paints. Besides, we use zinc oxide, zinc sulfide, lithophone also as white pigments. Now, as I already explained, there are some non-opaque, that is powders with less hiding power, and they act as extenders, like in the case of calcium carbonate, talc, barium sulfate, mica, silica, clays, etc. So they are all called false pigment, that is pseudo pigments. They appear white but do not hide the surface. Such powders are used as extenders in paints. They are just fillers to reduce the cost of the paint. The quantity of extender is more in case of primer and primer surfacer. And there are some iron oxide and chrome oxide pigments. They are synthetically made, that is with rich colors. For instance, chrome yellows are very, very popular. We have got lemon chrome, middle chrome, then scarlet chrome. We have got various colors, and these are all the different yellow pigments, okay, with the different orange tones, etc. Now, on the mass tone and reduced tone. So this is very important thing. I think that is we can discuss about this mass tone and reduced tone of a pigment. How to check this? This is one of the important characteristics of paint, so that we can evaluate, we can validate the quality of the pigment, particularly with the help of this mass tone and reduced tone. So I will explain about this two tests related to pigment to evaluate the quality of the pigment in the next video. Thank you very much for watching this video. Welcome, my dear friends. In today's technical session on the topic series Introduction on Paint Technology, I'll be explaining about the various types of pigments and how to test these pigments for its quality. As we already discussed in the previous session, we have pigment and pseudopigment. Pseudopigments means false pigment, like china clay, then barium sulfate, calcium carbonate, mica, soapstone, etc. So these are all called extenders also. But they are not true pigments. But when we talk about true pigments, we have white pigments and colored pigments. It can also be classified as inorganic pigment and organic pigment. Now let us discuss in detail. We are already familiar with some pigments like titanium dioxide, zinc oxide, zinc sulfide, lithophone, etc. And we know something about the chrome pigments. Now, let us see the iron oxide and the chrome oxide pigments. They are also available as a synthetic pigment. They are made rich in color. We have got chrome pigments. These are all yellow chromes. This is lemon chrome. This is middle chrome. Middle chrome will be orangish or reddish, whereas lemon chrome is greenish. And we have other type of a lemon chrome that is also much greenish one. So this is chrome, this is middle chrome, this is lemon chrome. And we have plenty of chromes, like that is we have got the primary color as well as the reduced color. Reduced color means that is its depth is somewhat low, that is it is something like a pastel or light shade. So we have middle chrome, light chrome, deep yellow, lemon chrome yellow, and we have orange chrome, zinc chrome. Then we have got various molybdenum, red chrome. Then we have molybdenum, red chrome 207. So you can find some tonal variation based on the grades. So likewise we have different types of chromes. And you can see on the right side they are mixed with white, so that they are available as reduced tone. Then we have to check two important parameters as soon as you receive the material in bulk. The main thing is mass tone and reduced tone. The mass tone is nothing but we have to make it as a paste with the required amount of oil. Like we can make use of this linseed oil or any other semi-drying oil. So you take a pinch of quantity, I mean a small quantity of pigment and small quantity of semi-drying oil, that is a linseed oil, and make it into a paste. It should have somewhat like a buttery consistency. Now we can either make use of the hand muller or the that is electrical pigment muller. This is the electrical pigment muller, and we can make use of the glass paperweight also, and that can be ground on either a granite or that is a ground glass slab. Now we have to make it as a paste and apply on a glass slide so that we can match the color. Okay, so this is the first one, mass tone. Reduced tone means you have to mix it with white, especially titanium dioxide rutile. So in the required ratio, for example 1:10 or 1:20. Okay, so based on that you can check along with your standard so that the tinting strength can be evaluated based on this. So this mass tone and reduced tone are the two important parameters we need to check so that we can have some good idea about the pigment and its tinctorial or tinting strength, that is coloring strength. And then we need to arrive at the proper pigment binder ratio, and for which you have to select the appropriate binder, in this case the resin. So the selection of resin is also very significant. Okay, so you can go through a book written by Turner. It's a very good book. It's available in Google and Amazon also, so you can check it. And this is the title is Introduction to Paint Chemistry and the Principles of Paint Technology by G.P.A. Turner. So this is one of the best books I can recommend if you want to have better understanding about the chemistry of paint. Now as I already discussed, see, that is either you should have a ground glass slab or granite stone. So it can be of a 3 feet by 2 feet size. So over which you can make use of that is you need to have such kind of a doctor's blade with which you can make it as a paste. The pigment can be made into a paste. So this is called mass tone, and this is the reduced tone, and this is also called a tint tone. So you can take that is a small amount of fixed amount of pigment and grind it into a paste using the linseed oil, so that you can apply this as a paste on the that is either on the glass plate, or you have got the tinting chart also, so over which you can apply, so that you can simultaneously check the hiding capacity, hiding power or opacity of the pigment. Anyway, so this mass tone and reduced tone, as I already explained, that is it is mixed with titanium dioxide rutile to the fixed ratio like 1:10, and we check the color strength also. Okay, right. And now this is the mass tone chart, where you can find this is the standard, and suppose the material which is supplied as a bulk one maybe having some slight difference in the tonal variation, and that can be immediately that is evaluated, or it can be given as a remark saying that in this case this is the standard and this is the bulk supply, that is the supply sample. So this is less reddish. So this is the way you can interpret the mass tone either. And as far as assuming that the right is standard, left is supply, means you can say this is dirty or reddish. Okay, so likewise you should be able to interpret the color, and not only that, you can find the opaqueness of the pigment by applying on a black strip. Okay, so that you can find out. Now you can see this is transparent, whereas this is translucent, whereas this is opaque, that is it has hidden the black surface. So based on that we can distinguish the opacity, that is hiding power of the pigment. Okay, right. So opacity means hiding power of a pigment. When you have got the least opacity, it represents more transparency. It means this may not be a good parameter as far as pigment for paint is concerned. Okay, so for a true pigment it should have best opacity or the hiding power. Now dye is something, it is transparent. The process of dyeing is totally different from painting. So dyeing is the interfacial coloring, that is it penetrates into the substrate, whereas a paint is applied on the surface, so where the hiding or the opacity is very important. Right. Now let us consider there are some essential pigment properties, like that is you have to check the color, mass tone, reduced tone, then opacity, and then color strength. Then light fastness can also be found out, whether the pigment can withstand maximum exposure and a longer duration to the sunlight. So all these things are practically examined. Light fastness and weather resistance means, that is how far it can withstand to extreme weather conditions. Okay, then heat resistance, then insolubility, because pigment is supposed to be inert, it should not be chemically inert, chemically reactive, so it should be inert, and especially it should not be soluble in water and in any major petrochemical solvent, particularly xylene. Then we have to check other chemical resistance, and the price should also be matched. So we had to compare like this. Then now let us compare the inorganic and organic pigment. Inorganic pigment has very good hiding power, whereas organic may have, that is less hiding power. Okay, and particularly when the light, let us consider irrespective of the inorganic or organic, when a pigment has lower hiding power, what could be the result? It means when light falls on the pigment, it does not reach the deeper in case of a good pigment. If it is not having hiding power, then definitely it will have the transparency. Okay, so that will affect the stability of the pigment also. Now you can see in the case of dye, it is so transparent, and in case of paint, it is opaque. So opaqueness is much recommended in the pigment that is used in paint. Okay, whereas the dyes are more transparent, is it not? Right. Then now let us talk about the varnish. Pigment plus varnish is equal to paint. That is, paint is nothing but pigmented varnish. Suppose if you remove the pigment from the paint, then it acts as varnish only. So varnish is nothing but resin, some additives, and some diluent along with some thinner. Okay, so it's also called clear. So especially on wood we apply varnish or wooden lacquer, and see, the stains are very important here. In fact, the wooden stains are the natural beauty, so it should be transparent and it should be visible. So these are all the different coating thickness of varnish, so that you can have different depth of colors also. Okay, so we've got various types of varnishes. Okay, right. So far we have discussed about mass tone, reduced tone, and we need to discuss about the texture based on the sea residue analysis, and we'll be discussing about oil absorption also as far as pigment is concerned. Okay, so we will continue this in the next session. Thank you for watching this video. Hi friends, welcome to this technical series on Introduction about Paint Technology. In this session, I'll be explaining about texture of a pigment, sieve residue analysis, that is a residue on sieve of a pigment, then what is the oil absorption, and what is water soluble of a pigment. As I already explained about this pigment, it is inert, it's a coloring matter. It should give color, it should hide the surface where the paint is applied. So these are the essential natures, characteristics of a pigment. It should be inert, it should not be chemically reactive, but at the same time it should hide the surface, and it should be finer so that it can be easily ground. And as far as colored pigments are concerned, the tinting strength, that is, to what extent the pigment can give the color value. For example, we cannot always have the straight colors. Sometimes we may have to blend with white to get the pastel shade. So in that case, the tinting strength is very important, and that is interpreted in terms of reduced tone. So we have already discussed about this tinting strength. Now let me proceed with the tinting strength as well as oil absorption. Because when you reduce, when I say reduce or reduction of a pigment, is nothing but blending the color pigment with white with various ratios like 1:10 or 1:20 or 1:5. Usually the recommended ratio is 1:10. Let us consider a pure pigment. It can be tinted to acquire various shades. Sometimes the pigment can be blended with black also to get the dirty or darker shades. Here there are some important terms associated with the tinting or the pigment, tinting of pigment. So we have got the pure white and pure colors, and we have got black. So gray is the blend of white and black. And similarly, when you tint a pure color, you are able to get a particular tone or shade. And with the blend of gray, you can achieve the tonal variations also. So I hope now you should be familiar with these terms: white, gray, black, tint, tone, shade, pure color. As I already mentioned, when you blend black and white, you are able to get gray. When we blend yellow and blue, we get green. So we have the primary colors. They are red, blue, green. So when you mix up these primary colors, you are able to get different shades. And in fact, the center color is white. That is, mixing of all VIBGYOR, violet, indigo, blue, green, yellow, orange, red, leads to white. That we have already studied in the refraction and the dispersion of white light. Now, generally, color mixing is based on the two important aspects, RGB and CMYK. In fact, this RGB, that is red, green, blue, is of additive nature. And this can be created by mixing lights also. So RGB is the additive color created with light. Whereas CMYK, this is based on ink. This is created with ink and this is subtractive. In fact, the printing industries follow CMYK. Color monitors where light is used. Here you have got cyan, magenta, yellow, black. On the other side, red, green, blue. So CYMK means cyan blue, yellow, magenta, and black. In fact, these are all the natural sources. Newton identified VIBGYOR in sunlight: violet, indigo, blue, green, yellow, orange, red. And when we look at this color wheel, this is the traditional one. So we have got this yellow on the top, violet at the bottom, orange or red at the right, blue at the left. Now, by mixing properly, you are able to get, for instance, when you mix yellow with the red, you will get orange red. Here the portion of red is more. By adding more amount of yellow, we are able to get orange. And by adding more amount of yellow to red, we are able to get yellow orange, and finally that is yellow, that is the pure color. Similarly, in between red and violet, you have got red violet, and between blue and violet, you have got violet blue, and between blue and yellow, we have got green, and in between the blue and green, you have got a bluish green, and in between yellow and green, you have got greenish yellow. So by suitably blending with appropriate ratios, we are able to get different colors. This is called the traditional color wheel followed in industries. And as I already mentioned, when you combine red with blue, you are able to get violet. When you combine blue and yellow, you get green. When you combine red and yellow, we get orange. When all these colors are mixed, it becomes gray. When all VIBGYOR colors are blended, it becomes white. And that's why sunlight is white, but on dispersion, we are able to get VIBGYOR effect or the rainbow effect. Now, in fact, based on these color combinations, we have almost exceeded 1 million color variants. LCD screen displays almost 16,777,216 combinations of shades. And that is why we can enjoy the beauty of nature, color, material, things, etc. in the LCD screen. We have now the printing combination of 1 million color variants using CYMK colors. I hope now you believe you should understand that the potential of the primary colors and the combinations and the consequences or the results. In fact, there is a psychology about selection of color. For example, for an optimism or for clarity and warmth, we have yellow color. For friendliness, we have orange. For the excitement, we have got the bold red colors. And for creativity, we have got the lilac, that is violet. And in order to get the trust and strength, we get blue color. And for peacefulness or for health, green color. So balance, gray is the calm one. So likewise, even the logos have been created based on the different colors and its impact. And we should understand the psychology of color even in interiors. For example, the appropriate color for an office room is blue. And for bedroom, it may be nut green. And for girls' room, it can be pink. For dining room, can be red or orangish red. For living room, it can be lilac or violet, and for kitchen, it can be yellow. So likewise, we've got different choices based on the lifestyles also. And there is a color psychology about the cheerful or warm or most likely straining colors. So these are all indicated here. Now, here, as I already mentioned, you can go through this. These are all the various icons and colors and logos that is in order to catch the attention of the customers. They are developed. So colors influence business. I hope now it's obvious that colors have great influences in our life. And we have already discussed about the mass tone, reduced tone, tinting strength, and you should try to understand the light fastness property. For example, how far, to what extent the pigment can be adherent to the surface with respect to the natural exposure or perspiration or that is a water or atmosphere or humidity, etc. So based on that, we talk about the light fastness, perspiration fastness. Fastness means that is how far the color is adhering to the substrate. And when we talk about the texture, this can be analyzed by using an appropriate sieve, and this procedure is called sieve residue analysis. It is something related to the fineness of pigment. Generally, the pigments are having 63 microns. So, when we grind the pigment along with the binder, we are able to achieve the fineness of this pigment. We may even achieve a few microns also with the help of grinding. And this is the micron size chart. So here, for example, hair is almost 100 microns dia. Pollen, spores, so these are all in the range of 100 microns. And bacteria is in the range of 10 microns. Then tobacco, smoke, household dust 1 micron. And less than that, we have got 0.01 micron, and that is the size of virus. And that is why the filtering of air is very, very important. But compared to the size of the dust, household dust, and micron, the size of virus is much less than that, and that is why they are adherent over the dust particles, and through that we are affected. And let us talk about the that is mesh size. So this is a mesh size of sieve. Usually sand particles are measured in mesh. So we have got the filtering equipment or filter with a different size of mesh. So we will have the stack of different filters with a different mesh size. And with the increase of sieve size, the particle fineness increases. When I say 100 micron, it is coarser. 200, when I say 100 mesh, the particle size is somewhat coarser. 300 means finer. 500 means much finer. 600 means much more finer. So with the increase of sieve size, the particle fineness increases. And you can look at this from this graph. So with the increase of sieve size, you can find the degree of what the perfect fineness will be increasing. And now we should talk about the sieve residue analysis and oil absorption. So these are all the various filters with the different mesh sizes. And in fact, this distribution of particle size is quantitatively determined by performing the mechanical analysis, which is called the particle size analysis. It is carried out in two parts: sieve analysis and sedimentation analysis. The distribution of gravel and sand particles is determined by the sieve analysis, and that of the silt and the day by silt and clay by sedimentation analysis. Now the particles are uniformly distributed, and this is done by ROS, that is residue on sieve. And we have to check whether the particles are of a uniform size, and that can be tested by using this technique called sieve residue analysis. Most of the natural pigments have different particle sizes, so we may not have uniform size. So the normal particle size should be 63 micron for paint industries when we get the pigments as raw materials. And micronized are available in 32 microns. They are called micronized pigments. So finer the particle size, greater will be the surface area. Now let us try to analyze this. For example, we have got this cube. Let me assume the side of a cube is 2 centimeter. We know it has got 6 surfaces, that is 6 squares. So lateral 4 and top and bottom each one. So totally 6 surfaces. So let us calculate the surface of this cube. We know the formula, the total area is 6a squared. So 6 into a into a, it means we have got 6 into 2 into 2, that is 24 square centimeter. That is the total surface area, right? And let me break this into, that is 8 cubes. That is, I am equally dividing at all sides. So we are able to get 8 cubes. Now let us calculate, and the size of each cube, the side of each cube is 1 centimeter, right? And we have got 8 pieces. Now what about the surface area? It has increased to 48 square centimeter. How? Because for 1 cube, 8 surfaces, 8 into 1. Likewise, we have got for 1 cube we have got 6 surfaces. Likewise, we have got 8 surfaces. So 8 into 6, 48. So you look at this, the one which was originally with the cube with the size 2 centimeter has got 24 centimeter. But when it is divided into 8 small cubes, it has increased to 48. So by dividing equally, we are almost doubling the surfaces. From 24 to we have achieved 48 square centimeter. It means by reducing the particle size, we are increasing the total surface area. So in that case, the problem of wetting will be there when we reduce the particle size, and that is why we introduce this term called that is oil absorption. Oil absorption, as I already mentioned, finer the particle size, greater is the absorption of oil. So this oil absorption is an important phenomenon in deciding the glossiness of a paint. We decide the pigment binder ratio in a paint. So based on this pigment surface area, we need to calculate the amount of pigment to make a particular paint. For instance, it's applicable for both pigment and extenders also. So let us have a pinch of paint, a weighed quantity of pigment. Let us add slowly this oil. It can be a linseed oil, and when we make this into a paste, okay, so we have to just wet the pigment surface, okay. And what is the quantity of oil required for just to make it wetting of that particular pigment? That is called oil absorption. Okay, so finer the particle size, greater will be the oil absorption. For example, let us have the pigment filler ratio. So here, oil absorption intake and water absorption intake. So it varies based on the type of pigment. For calcinated kaolin, it is a 45, and WI, that is water absorption index, is 48. Now let me focus on oil absorption. For talcum, 30. For calcium carbonate, it is 19. You just look at it. So talcum is much finer than calcium carbonate. Then titanium dioxide, it is just 25. For us, black iron oxide is only 16. It means that is the black iron oxide has lower value than that of the yellow iron oxide, which is 35. So likewise, we have various colors. You just check it up, this ultramarine blue, it has got only 16. So oil absorption index and water absorption index, it may vary with, that is material to material, that is pigment to pigment. Now, I hope that is for water-based compounds, that is water-based formulation, paint formulation, this water absorption index is very important. And for oil-based paints, this oil absorption index is very important, and that decides the sheenness or matteness or glossiness of the paint, right? And here, when we talk about the pigment volume concentration, you should be aware of these two important parameters. One is called PVC, another is called CPVC, that is critical pigment volume concentration. So pigment volume concentration is nothing but the ratio between the pigment volume, that is volume of the pigment, and the sum of volume of pigment and volume of resin. So here, the critical pigment volume concentration is also another important parameter, and it is the point at which the right amount of binder is present, which can soak all the pigment particles and fill the existing gaps. For instance, suppose if PVC is less than CPVC, that is critical pigment volume concentration, it indicates that the pigment portion is less, binder is more. So naturally you can say it will be glossy. And when the pigment volume concentration is almost equal to this one, that is, it will be normal one. When pigment volume concentration is exceeding the critical volume concentration, there is a tendency towards the matteness. So it decides, this pigment volume concentration decides the glossiness of the pigment. Okay, so I hope that is you would have gone through these different parameters about the pigment, and in the next session we will continue the remaining topic. Thank you for watching this video. Hi friends, welcome to my technical series on surface coatings. So in this session I'll be explaining about the coating performance and how to select a particular coating. There is a great word in Tamil regarding the purification of food. உணவின் தரம் என்பது மூன்று வகைப்பட்டது. பாக சுத்தி, பதார்த்த சுத்தி, பாத்திர சுத்தி. That is, if you expect a good quality food, first of all, the process of food should be of high standards, high quality. It should be very pure. And it also depends on the performance of the cook. Then it depends on the purification or the quality of materials we use in the food preparation. Then it also depends on the quality of the container in which the food is stuffed. Similarly, the quality of coating is also dependent on the formulation of that particular type of coating, then the raw materials used in that paint or finish or coating chemical, and how it is packed. That is also important. The container is very important. It takes a very significant role in paint industries. Then how it is stored and processing, then how it is applied at the customer's end, and with all that, the customer should have the complete awareness about the usage of the paints. Let me explain about the metal finishing here. Here, it depends on the quality of component. It depends on the design of the component. Then metal pre-treatment, what kind of pre-treatment we are going to give before coating, and what is the nature of the first coat followed by the top coat. So let me explain one by one. Here, as far as the sheet metal is concerned, we got two types of metal. ferrous and non-ferrous, iron-based and other metals like aluminium, galvanized iron, copper, brass, bronze. In fact, we can put this under ferrous also, GI, galvanized, because there will be a zinc coat over the iron sheet. Then we have under ferrous cast iron, mild steel, stainless steel, and we have got different types of stainless steel like 224, 316, etc. Then, in fact, we need to justify first of all what type of coating will withstand over which type of metal. So this is very, very important. Then, as far as the design part is concerned, that is, it should not have sharp edge, because according to the physics of action of points, there will be more charge accumulated on sharp edges, so that the material will have greater tendency for rusting or oxidation or preferential electrochemical corrosion. And that is why most of the designs are nowadays of curved nature, curved surface, so that we will have lower extent of corrosion. Instead of designing a Jeep like this, you can think of having a shape like this, a curved one. Why? Because in this sharp edge, in fact, the coating thickness will also vary. Let me say in sharp edge, we are given the coating like this, and here we have given the same coating, but the problem is you will not achieve the coating here, the required coating here. So there is a chance of penetration of any detrimental elements through this lower DFT, that is dry film thickness. And that is why if you coat like this, it will be uniform, so the coating thickness will also be uniform. That is why people nowadays prefer curved surface, and it should be free from silent corners. So the design engineer should take care of these aspects. Then try to reduce the welded area. We cannot simply avoid the welding, but that is try to minimize that. And you should have a specialty coating for the welded portions, because that will trigger the electrochemical corrosion at that particular point. You could have seen such type of rust preferentially taking place on the welded portions. Then, as I already mentioned, if it has two different components, then you have to make it sure that they should have the same property or similar property. Suppose if it is a stopping enamel, it's of a different specific resistance means probably the extent of curing will be different as far as thermosetting acrylic paints or any stopping epoxy or stopping enamel paints are concerned, because the absorption of heat will be different based on the specific heat capacity of that particular material. Then here as far as the pre-treatment is concerned, because you may be having very top quality paint, but unfortunately if it's not prepared properly, then it is of waste. So you have to give a better metal pre-treatment. Either you can go for zinc phosphating, or you can go for nano ceramic coating, and sometimes some people prefer self-etch priming, as in the case of non-ferrous metal. In fact, we give consultancy services for all these kinds of metal treatment, pre-treatment. And then the top coat. As far as top coat is concerned, some people prefer liquid paint, and most of them nowadays prefer powder coated system. Under liquid paint, you have stopping enamel, stopping epoxy, thermosetting, acrylic. All these three are heat cured, that is, it can be cured only at higher temperatures. And we have got some low bake enamels also. Nowadays, some accelerated curing along with hardener packed items like polyurethanes also available. And we have two pack system like epoxy amine and epoxy amide. And over that, some people give glaze coat, that is top coat, top clear coat. It's called a glaze coat. So that, and here the mark proofness, that is, it should be scratch proof. So in order to have a better aesthetic value, this kind of paints, or the clear coats are given nowadays. And then as I have already explained, in powder coat we have got different systems like urethane, epoxy, and epoxy amide, polyester, etc. Then the purpose of coating. Here we should understand for what purpose you are going to give the metal finishing for your component. For example, whether you are very specific about anti-corrosion or weatherproofness or waterproofness or chemical resistance or heat resistance, and with all that you had to specify whether it is food grade or commercial grade. So these are all very, very important. And as far as salt spray is concerned, that is anti-corrosion nature is concerned, that is you have to fix the number of salt spray resistance hours in terms of 240 hours. Whether you require like this, you have to discuss with your customer actually. So whether it is for 240 hours or 400 hours or 600 hours or 1000 hours, etc. Okay, so based on the salt spray resistance, we have different types of chemical constitutions of coatings. Then you have to maintain these standards like Bureau of Indian Standards. This is our Indian standard, and some people, based on the customer, they have to adhere to this British standard, and some companies they insist for ASTM, that is American Standard Testing Methods, and if it is a Japanese company they will insist for Japanese Industrial Standards, JIS. Then there are some DIN specifications for German based companies, and we have sometimes international standard organization, they may insist for ISO standards. Similarly, we have to be very careful when we select our suppliers. You have to check whether they have complete technical know-how for the proposed project, and with whom they have collaborated, and what are the standards they are maintaining, what are their internal standards, and what are the internal standards you can develop along with their, with your suppliers. Then consistency of their supply, then technical competency, and what way that is that they can cooperate with us. All these things should be taken care of when you select any supplier. And then internal standards. As far as internal standards are concerned, that is your raw materials are very, very important in determining the quality of your end product. So you should have stringent raw material specifications, and you should have developed internal standards, and for process also you should maintain standard operating procedure. Then you should have a firm quality policy, and better you can have some training for quality circle activities, so that it will improve the team performance and good working culture. Then you should adopt the statistical quality control. Then there should be regular training, and then you should treat the next stage operator as your internal customer. So these are the internal customers. So within the processing cycle you must support. Then, as I already mentioned, with all this you can achieve the end quality, the end product quality. And with all that, even after the sales, that is, you should try to get the customer feedback, and after getting the customer feedback, if there is any complaint, we have to maintain the complaint investigation report. And then you should have a total dedicated after sales technical service team. Then you should have a regular consultancy, so that he'll be acting as your internal guru. In fact, that is, I am very interested to collaborate with your organization as your mentor, as your guru, as a consultant. If you have got any requirement, you can contact me. Thank you very much. Good morning. Today let us talk about the grinding aspect of pigment. How the pigments are ground into a paste along with the part quantity of resin and part quantity of solvent, and a few quantity or few amount of surfactant required, like wetting agent, anti-settling agent, etc. To start with, let me explain about wetting agent dispersing additive, flow additive, leveling additive, and I will explain also the deformer, deaerator, then rheology modifier. Rheology modifier means the settling aspects, because the paint consists of pigment, some solid material suspended in the vehicle. Vehicle is nothing but here the resin part and the thinner part also. So these pigments should be properly mixed and should be available as a homogeneous mixture. That is very important. So after grinding, it should be maintaining the same phase of homogeneous, that is single phase. So in order to attain that characteristics, we have to necessarily add the anti-settling modifiers or settling agent, anti-settling agent. Otherwise what will happen, the paint and pigment, that is the vehicle part, that is varnish and pigment, will be separated and it doesn't look nice and you will not get uniform mixture. So that is why we need to add this rheology modifier, which is also called anti-settling agent. And the paint has to be dried, is it not? So we need to incorporate the dryers and some catalysts. Okay, sometimes in case of 2-pack that is the paint, so we need to add appropriate oxidants also. Okay, now let us discuss about the other types of paints also, like we are able to get solid finish and metallic finish. So for metallic paints, after all, they are all based on aluminum particles. So you could have seen the aluminum paint painted on the bridges and in the transmission parts and also in metallic cars. So these are all called metallic paints and they are based on aluminum paste. There are two types of aluminum paste. One is called leafing aluminum, another is non-leafing aluminum. I'll get into the detail later about these leafing and non-leafing, but try to understand that this aluminum leafing paint is giving very shiny aluminum like or silvery finish, whereas metallic or dot like finish is obtained by using non-leafing aluminum paste. In fact, this is applied or this is dispersed with a varnish and applied as aluminum paint. So you have to take the considerable amount of binder, that is a resin or varnish, then mix this aluminum paste and thoroughly, then it is made as aluminum paint. So there is no grinding part involved here. Simply by mixing you can get this wonderful finish. And we have got different metallic finishes also, and we have got variety of colors, and using tinters we are able to get different types of finish also. And this is also used as a base coat, that is aluminum base coat, over which flamboyant shades, that is organic dye based paint clears are applied, so that you are able to get a candy finish, that is something like a candy tone finish is obtained by using aluminum base coat followed by the colored top coat. And so this is probably, that is as I already suggested, this leafing aluminum paste is used in transmission parts, and a non-leafing that gives aluminum, that type of aluminum paste gives very good shining metallic finishes also. And so here you would have seen in transformer they have applied the aluminum paint, that is they are using this leafing aluminum, and especially heat is transmitted in this kind of aluminum paint, and it can withstand the heat. So metallic paint standard, these are all called aluminum paint standard with the leafing aluminum paste. This should be mixed only at the time of application. So this is delivered or supplied and delivered as a 2-pack system only. And it's a simple job, and you will be given a definite ratio, that is a paste is to binder, and accordingly you have to mix it properly before applying the paint. Now you can simply, that is a buy varnish and a leafing aluminum paste and repack it. So this is in fact this is a hot cake. I would suggest to start with. You can make use of this kind of paints, aluminum metallic paints and non-leafing aluminum paints also. Then and here that is as I already suggested, you could have seen such kind of candy finishes in bikes, bullets, etc. Okay, so these are all called candy tone red. On petrol tank you would have seen, and even on electric rice cooker you are able to see such type of candy colors. So we have got different, very lustrous, wonderful colors. Okay, then and even in heaters, water heaters, and nowadays that is even beautiful cars are finished with such type of flamboyant shades, and cookers, pans. So and they used to give a pearlescent finish also. So these are all called the pearlescent effect. Okay, so this is a wonderful finish, and pearl coat is also a type of special pigment, and where by mixing suitably over selected color like black, you are able to get different colors. So these are all called pearl finishes. Okay, so as I already recommended, here no grinding is required. Only thing is you have to mix it with a mixing rod, and metallic finishes are supplied as such by mixing, but aluminum paint standard, that is with an aluminum, that is a leafing type, it should be mixed only at the customer or consumer end, okay, or client end. Let me explain about the pigment binder ratio. Pigment binder ratio. Then there is an important term called oil absorption, and we should know something about the pigment volume concentration and critical pigment volume concentration. So these are all the important parameters which are very frequently used in formulation, paint formulation. So let us study this deeply. We know the paint is nothing but pigment plus binder and it needs some additives. Along with that, we used to add thinners, a combination of or mixture of solvents. So here the pigment binder that decides the quality and the type of finish also. And additives are added in small quantities for a particular purpose, and thinner to adjust the viscosity and to obtain a better that is type of application also. For example, if it is a spray type or dip type or brush type, we have to adjust the viscosity using this thinner. Thinner is a blend of solvents. Now let me talk about this pigment binder. As I already initiated with the pigment binder, so pigment binder ratio is very important. So here the oil absorption is a very important term. Oil absorption is a very important term. It is nothing but the quantity of oil, the amount of oil, you can say, quantity of oil, the quantity of oil required just to wet the pigment. Okay, just to wet the pigment. And for example, let me consider chalk powder and talcum powder or face powder. So this is very, very fine, whereas chalk powder is coarser. Now let me mix with a binder. In fact, it would be easy to wet the chalk powder with certain amount of binder, but wetting the talcum powder is a tough job because of poor wettability. Why this poor wettability? Because of fineness. The degree of fineness or the particle size is very, very fine. In this case, it is coarser. So finer the particle size, greater will be the surface area, and that is why, so we can mark like this: finer the particle size. Finer means you are reducing the particle size. Finer the particle size. What do you mean by that? Particle size. Finer the particle size means, that is, I am reducing the particle size. And greater will be the surface area, and thereby the wettability also increases. That is, ease of wettability will be difficult. Okay, decreases. Wettability decreases. You cannot easily wet. So, based on the selection of pigment, you have to consider essentially the oil absorption, as I already mentioned, the amount of oil required to wet the given quantity, given amount of what? The oil. And in the case of, because we are using enamel and water-based paints, emulsion paint, water-based paint. So in the case of emulsion paint, in the case of water-based paint, we had to consider the water absorption. Usually it is given as index. And here in the case of enamel, that is oil-based enamels, we use this term, that is oil absorption, you can call it index. It is given as a percentage also, or as an index value. For example, if you take talc, the oil absorption index will be 30, but the same talc, the WAI is around 34. If you take, that is calcium carbonate, calcite, CaCO3, and let me take 1 micron, micronized, very fine. In that case, it requires, that is 19 grams to wet the surface, that is 19 is the oil absorption. And titanium dioxide, TiO2, titanium dioxide. So its oil absorption. Now let me define more on this subject rather than the water absorption index. So titanium dioxide, it is around 25. Then black iron oxide, and for which it is 16 is the oil absorption. And similarly for chrome oxides, it will be 10. And for red oxide, it is 23. So likewise, we have got different values for different types of pigment based on the coarseness and the nature. This is 23. If it is a ultramarine blue, the value is around 16. Now let us discuss about the pigment volume concentration. That is a very important parameter in paint formulation. PVC and critical pigment volume concentration. So PVC is nothing but the ratio between the volume of pigment divided by the volume of pigment plus the volume of the resin. This is a very important formula. So VP means volume of pigment and VR means volume of resin. You know, the density is nothing but mass by volume. So, using or knowing the value of density, the volume of pigment can be obtained. So, volume is equal to mass divided by density. Are you able to follow? Mass divided by density. So, this formula can be effectively used for determining the volume of pigment. Let me go slowly, step by step. Critical pigment volume concentration. So this is PVC, pigment volume concentration, that is volume of the pigment divided by the total volume of pigment and the resin. As we already seen, we consider only the pigment and the resin. Resin is also in this case known as binder. So pigment plus resin, these are the two major ingredients in paint. So what could be the volume of the pigment in the total volume of pigment and resin? So that is the concentration of pigment, that is pigment volume concentration. I hope now it is pretty clear. CPVC means critical pigment volume concentration. It is the point which the right amount of binder is present. The right amount of pigment, the right amount of binder, the right amount of binder which can soak all pigment particles. And fill all the existing gaps. Okay, in other words, it represents the for example, it is a kind of circumstance in which almost let us assume the pigmented or the paint has 100% coverage devoid of all gaps. That is, there is no gap at all. Let us assume like this. For example, let me illustrate further on this topic. See, let me call it this as the binder and this as pigment and this is yap. So this is binder, this is pigment, this is yap. Let us assume like this. Now when the pigment volume concentration is less than critical pigment volume concentration, It means you got the binder. So the binder consists of what? The pigment with various particle size, like this. Okay. So here the pigment volume concentration is less rather than the binder volume. So this is the binder and this is the pigment. I hope by this illustration it is very clear. And let us assume pigment volume concentration is equal to critical pigment volume concentration. It means we have a binder surface area and we have got equal amount of pigment volume also. So here we have these are the pigment volumes. So the remaining space or binder. So here the pigment volume and the binder volume is almost the same, and that is why it is called PVC is equal to CPVC. And if there are any air gaps, it means that is a PVC is greater than CPVC, where you can find okay. So these are all the pigment volumes, and besides that you have certain air gaps also. So in that case PVC is greater than CPVC. So when PVC is less than CPVC, now the paint is glossy. Are you able to understand this? The paint is glossy. It means the binder portion is more. The binder ratio is more. Okay, but if there is a more amount of binder, there is a problem of coverage. So you have to strike the balance between this coverage and glossiness. Let me explain about hydrocarbons. Because most of the chemicals are used as solvents. So we have to know the basics of hydrocarbons first of all. This can be classified into two: aliphatic hydrocarbon, aromatic hydrocarbon. Hydrocarbon means carbon and hydrogen are present. Aliphatic hydrocarbon, we can start with, this can further be classified into three, simply speaking: alkane, alkenes, alkynes. So these alkanes, we are going to use this alkane as a solvents, some of the gases also. For example, we start with CH4. Its general formula is CnH2n plus 2.
I am not going to discuss about the alkenes and the alkynes. So let me focus only on alkenes. So methane, if there is one carbon, 2 into 1 plus 2, 4. So CH4 is the molecular formula of methane. It's a gas. It's highly inflammable. Then we have C2, 2 into 2, 4 plus 2, 6. So C2H6. This is ethane. And C3H, 2 3s are 6 plus 2, 8. This is propane. C4H10, because 4 2s are 8 plus 2, 10. This is butane. Likewise, it goes. In fact, with the increase of carbon atoms, they behave differently. It consists of one carbon atom. This is 2 carbon atoms, and it has 3 carbon atoms. This one has 4 carbon atoms. And if we proceed further, that is C5 to C7, they act as solvent. And in fact, this range is called light petrol. Light petrol, also used as fuel. And the motor fuel is having C6H11, C6 to C11. So this is the petrol, and this is used for fuel. So with the increase of carbon atoms, it results in wax, a solid state. It starts from gas and becomes liquid, and with the increase like a C18H22 or C16H C20, this range is used in lubrication oil. Lubrication oil. And paraffin wax ranges from C20 to C30. So this is wax. And after that you are able to get coal tar or asphalt, that is C30, C40. C30, C40. In this range you will have tar product. So one thing is clear. So with the increase of the carbon atoms, the boiling range also increases. Are you able to understand? Here for methane the boiling point is minus 161 degrees Celsius. It means it catches fire readily and it is in the gaseous state. Its boiling point is much less than the room temperature, because the room temperature is around 30 to 33 degrees Celsius, and that is why it exists as gas and it can easily catch fire. And this butane, this is used in domestic purpose, and this is the domestic fuel, gas. We call it gas, Indian gas, Bharat gas, etc. So this is the gas used in the fuel. This is also gas. So with the increase of carbon atom, what happens here? The boiling point increases, and with the combination of this mixture of C5 to C7, it will not exactly a single point as boiling point. Instead, it will have a range, because it consists of a mixture of solvents. So starting from, for example, C5 to C7, in this range, the boiling point ranges from 20 to 100 degrees Celsius. Are you able to follow? So in the case of lubricant, you know very well, lubricant is almost oily. It is not at all evaporating. Okay, this roll having about 300 degrees centigrade. And in the range of kerosene, so the kerosene actually they come under in this range like gas oil C13 to C18 like that. So likewise, with the increase of carbon atom, the boiling range increases. So this is as far as aliphatic hydrocarbons are concerned. Then when we look at this aromatic we can start with benzene. C6H6 is benzene. It will have a structure like this. Alternative double bond will be there. So C6H6, benzene, ENE. And if you have got one methyl group, then it is called toluene. That is, this is also aromatic. This is toluene. And this one is called xylene. If it is in the ortho position, it's called orthoxylene. Orthoxylene. If it is a para position, it's called paraxylene. CH3, CH3. Usually we have the mixture of xylene. So the xylene mixture will contain both ortho and para. Okay. And toluenes, xylenes, these are all used as aromatic solvents in paint industries. And these are the major aromatic solvents. And we have some ketones also. For example, CH3, COCH3. This is called acetone. This is coming under ketone. And we have another ketone also, that is MIBK. It means methyl isobutyl ketone. This is also an excellent solvent in paint industry. Methyl means CH3. Then you have got CO group. And then isobutyl. Isobutyl means a C. There will be 4 carbon atom. CH3, CH3, CH2, CH. This is isobutyl group. And this part is methyl. So it is called methyl isobutyl ketone. And this part is called ketone. And we have ethers also. CH3, O, instead of CO, you have only O. So these are called ethers. We have got variety of ethers. This is dimethyl ether. Similarly, you have C2H5, O, C2H5. These are all fast evaporating ethers. This is diethyl ether. This is dimethyl ether. Okay, and we have alcohols also. So the alcohols will be having the OH functionality, OH group. So we have CH3OH. This is the methanol or methyl alcohol. Similarly, C2H5OH. And this is ethanol or ethyl alcohol. This is called the spirit. And you have propanol, that is propyl alcohol, C3H7OH. This is called propyl alcohol. You have got the butanol, that is C4H9OH. So this is the solvent frequently asked in resin industries. Butanol or butyl alcohol. Okay, and you know something about this isopropyl alcohol, IPA. These are all used in cleaning the plastics. Isopropyl alcohol, propyl alcohol. That is isopropyl means CH3 CH3 and then HOH. So this is known as IPA, the famous compound, famous solvent. Is used for cleaning purpose. Okay, so likewise we have different types of solvents, and in all these cases the boiling point, evaporation rate, these two are very important besides the specific gravity. I will discuss one by one. Let me explain how to adjust the solvency parameter. Solvency parameter. The solvency parameter, let me consider a polyester resin. A polyester resin cannot be dissolved in N-butanol. So they belong to group 3. Its solvency parameter is 11.4. You can refer the table. Similarly, this cannot be dissolved by xylene. Its solvency parameter is 8.8. So this belongs to group 1. But by having a suitable ratio, let us have it, butanol is 1 part and this is xylene is 4 part. So butanol combination, butanol part is 1 part and xylene 4 parts. Let us have a mixture of this. So we can achieve the mixture parameter. Mixture of, that is 1:4 mixture of N-butanol and xylene. Let us work out the parameter, mixers parameter. So butanol is 1 part, so you can put 1 into 11.4, that is 11.4. And what about xylene? Xylene is 4 part, so this is 8.8. So we can have 35.2. Now let us add this. We have 46.6. And what is the part? 5 parts. So you have to divide this by 5. 46.6 divided by 5. So it leads to 9.3. And that is favorable for dissolving the polyester resin. So likewise, by using the combination of solvents, one can achieve the better dissolution of the chosen resin. Okay, so this is called the mixer parameter to increase the solvency.